The goal of science is to understand and master the universe around us, but could our skill grow so great that we could learn to warp reality itself? Possibly one of the hardest truths about shifting from science fiction to a science-realistic look at exploring and settling the galaxy is that leaping around the place at faster than light speed is probably never going to be possible. Still, there are some hypothetical technologies like warp drive that seem to offer the possibility of FTL travel, moving around the galaxy in years, or maybe even days or moments. However, we focus so much on this aspect of those sorts of technologies that we often overlook what other things warping space and time might allow, and some of these are even possible under known science. So I thought today we'd contemplate how we warp space, how we might be able to if we ever got our hands on negative mass or energy, and some of the cool technologies allowed under both known science and some more hypothetical options. We will not just be talking about warping space and time, as there are other quantities or qualities we might change, like probability and luck. We will be looking at everything from FTL to perpetual motion machines, or how to make enormous storage spaces, and the major topics we'll cover in order are warping space-time, negative mass, spaceship propulsion, force fields and shields, reversing universal expansion, matter creation, super strong materials, cloaking, Hammerspace, tractor beams, time manipulation and stasis, ultra-fast communication, vacuum energy, universe creation, probability manipulation and luck, and finally, perpetual civilizations. And we'll try to ask what sort of impact those would have on a society if they possess those technologies. Lots of topics to cover, so we'll be here for a while, and you might want to grab a drink and a snack. And don't forget to hit those like and subscribe buttons while you're at it. When it comes to warping space-time, we probably want to begin with the classic basic case of just normal old space. We'll get to space-time and negative matter and tearing space-time as we go. And I think folks know of this mostly with either the classic grid paper or rubber sheet case of seeing the moon orbit the Earth or the Earth the sun and press down on that grid, which can actually give you a bit of a backwards idea about what's happening since gravity contracts space around it, rather than stretching it out, but the visualization is a popular one. Let me instead suggest an actual 3D version of this and just picture a basketball or any other hollow sphere, which we will say represents a region of space. I could fill that sphere up with water, around 430 cubic inches or 7 liters worth. However, if we put a lot of mass or gravity in there, we would suddenly find that it wouldn't hold that much water anymore, and less as we added more mass, ignoring that the mass is taking up space itself, as in this case the water is just our analogy for space-time and isn't getting pushed out. That basketball, or region of space, looks the right size, but it's crunched down inside. There is literally less space inside there than your math tells you there should be. Indeed, if the mass is all concentrated near the center and we divide that sphere into shell regions based on how far from the center they were, we would find the actual volume of each successive shell, as we got closer to the center, was even more reduced than we would calculate that the previous shell was. It's getting more contracted, more warped as we get closer and gravity goes up. Now, if it were actually a black hole in the center, things get different and indeed space-time might even rip. But even in a mundane sphere of mass like Earth, this warping continues. At Earth's center, where net gravitational force is zero because there's equal mass and force pulling on you in every direction to cancel out, the warping is nonetheless at its highest, space is most condensed, and time runs slowest there at the center of the mass. So too, you don't actually need mass for this effect. Any form of energy does the warping. For most objects, virtually all of their energy is in mass format, but ultra-hot objects, or those with incredibly high spin rates, or kinetic energies, like neutron stars, do bend space-time significantly from their heat and kinetic energy, and a large pack of photons altogether, while having no mass, will also bend space-time. Under Einsteinian relativity, we generally consider gravity and its stretching of space-time to be unified concepts. The presence of large amounts of energy, usually as mass, warps space-time and causes the effect we think of as gravity. Gravity is a strictly attractive force though, so it only contracts space-time. It only makes space condense and only makes time slow down, not expand or speed up. Negative mass is a type of hypothetical matter with the opposite warping effect of normal matter. Space expands and time speeds up. In the rubber sheet analogy, the weight or spheres on the sheet lift the sheet rather than stretch it down. And in our earlier basketball analogy, we would find that it would now hold more water than we calculated, not less, more space and faster time. This is how the FTL effect is explained for warp drives. When it comes to spaceship propulsion, negative mass, as well as other alterations to reality, can be used for fast and low-energy non-FTL travel too, which avoids causality violation concerns, or time travel paradoxes. We have no known examples of negative mass or energy, though there is a kinda case with vacuum energy which we will get to later. If it exists or could be made to exist, and had the properties we think it has though, then you could put some normal mass on the front of a ship and some negative matter on the back of a ship, and you have a spaceship which will move without any propellant or outside effort. See, a property of negative mass particles is that they are believed to gravitationally repel both positive and negative mass, unlike positive mass, which is believed to pull on both positive and negative mass. Therefore, two positive mass particles pull toward each other, two negative mass particles repel each other, and a positive and negative mass particle will actually shove the positive mass away from the negative mass while pulling the negative mass toward the positive mass, resulting in the positive mass particle being chased by the negative one. This is what we call a gravitational dipole drive or reactionless drive. This does not imply FTL directly though, but the effect is a ship eternally falling down a gravity well. The negative mass is expanding space, or essentially putting the back end of your ship uphill, while the front is contracting it and putting the front downhill, and regular energy does that too, as would negative energy, so negative mass isn't required if you can generate negative energy instead. How this gets to FTL is a bit more complicated, see our warp drives episode for the details, but essentially this ship isn't moving through space, it is letting space expand and contract or warp near it, propelling it through space but without any propellant. I should note that we do have an example of space expanding already, and that is dark energy and the expansion of the universe in its entirety, and indeed most of it is expanding away from us at faster than light speed. Dark energy and Hubble expansion do not operate on the same principle here exactly, but they do give some hope that the rules of reality permit something like negative matter to exist or to otherwise produce that effect. The gravitational dipole drive is a specific subset of these sorts of drives using a ship stretched between two massive spheres, regular and negative mass, but the entire category of bias, diametric, and pitch drives contemplate warping some feature of reality to move a ship. Generating a negative energy pocket to emulate negative mass is just one example, but in theory you could just as easily flip the gravitational constant on one sphere to a negative value, or increase or decrease the power of the electromagnetic force behind or in front of a ship, or reduce the inertial mass of a ship. Warping physical constants is probably not possible and would tend to have huge secondary effects which folks forget though. For instance, you might make a ship whose hull could alter how much drag it had, but if this is being done through some sort of alteration of how atoms work, it might unbind those atoms or kill the crew as the laws of chemistry and viscosity suddenly change. Everyone has a heart attack when their blood won't pump through their veins anymore. We can also protect ships with shields or force fields, not just move them, by use of negative mass. Normally something like a projectile or laser beam is going to gain energy as gravity pulls on it, speeding up or blue shifting as it approaches a massive object, which makes them hit harder, but a negative mass field or negative energy field would slow projectiles and redshift light beams. While it's doing so, every punch you throw is being accelerated or blue shifted as it leaves your ship, while every shot your enemy gets you with has been slowed or weakened. And there's no particular reason this couldn't be used as a personal force field or on a smaller vehicle, except that it really does take a lot of mass to do much of anything gravitationally, so something like that might work better for megaships or giant space stations. Again though, we're not just limited to contemplating warping reality by use of gravity. It might be some field that did this specific effect, or it might be one that caused space to massively expand around a ship, like with Hubble expansion, so that while it was active, your enemies would have to shoot through a bigger volume of space towards you, and everything redshifted or slowed on approach. Though with a method like this, what we'll call a Hubble shield, your own shots are weakened too. Plus, there's no real reason why that newly added space would disappear when the shield went down, which might make for an interesting type of pollution. Your galaxy is slowly falling apart from excessive creation of new pockets of space, causing a localized Big Rip effect. The opposite effect, something that caused space to shrink, like a vortex sucking space-time out of it, could potentially be one serious doomsday weapon if it was the equivalent of ripping a hole for the universe to drain down. But assuming there was a limiter on that, you could use something like a targeting generator that laid that field down on an enemy ship, or produced it from a generator you could load onto a missile to aim at them, that suddenly made it so virtually every shot curved in on the target and hit with more punch. One can't imagine a specialized ship in a fleet whose job it was to put that beam on an enemy capital ship so the fleet could pound it twice as hard. On the flip side, you might be able to shield yourself from gravity, allowing you to hover over places or even escape black holes, as well as being awesome for space travel and building enormously tall structures. Something like being able to emit new space via artificial Hubble expansion toward that source of gravity might give you gravity shielding too. We could reverse Hubble expansion and dark energy if we seriously scaled up a device for sucking in bits of spacetime, and a process like this would probably be a power and energy generator, not something you need to supply it with to run. Spacetime has energy in it, as we'll discuss in a bit with vacuum energy, so collapsing or destroying bits of it should produce energy. This would probably make for one heck of a terrifying weapon too, in bomb or ray format. Space near or inside the target starts disappearing and replacing itself with huge floods of newly released energy and radiation. However, we don't know how dark energy works or where it comes from, if anywhere, so it might be something that eventually runs out, and the universe would then stop expanding. Indeed, it would eventually collapse if that energy ran out. But we have no reason to think it would, and that is essentially an infinite power source, which you could then harvest to run a civilization eternally. Such being the case, we don't know what form of energy that harvested energy would take. Maybe particle and antiparticle, photons, maybe regular old matter. I wouldn't be surprised if it came out formatted like things were right after the Big Bang either. Energy can be converted into matter if you have a sufficient power source that isn't deriving energy from mass, causing a surplus of power but maybe a deficit of matter with which to build things out of. But you can turn one type of energy into another, especially if you have an infinite power supply, so you don't really need to worry about your efficiency rate. Additionally, if you have various reality warping technologies, it should be possible to bias the rate at which various bits of matter are produced, and you may be able to create types of matter which normally wouldn't be able to exist. Super strong materials might be generated by any number of reality warping techniques, like locally increasing the electromagnetic force or strong nuclear force to bind nuclei or atoms together stronger, or create stable atoms vastly larger than uranium, or even the hypothetical island of stability. We also have no idea how strong materials made out of the other four quarks, charm, strange, top, and bottom, would be, as all our normal matter is made of just up and down quarks plus electrons, and you might have matter with muons or tau particles instead of electrons, or even warp reality itself to alter their basic properties or create entirely new fundamental particles. A proton of double mass or half charge, or something new that flicked back and forth between positive and negative charge, somewhat like neutrino-type oscillation. We could also imagine a mixture of negative matter with neutronium, the hyperdense material neutron stars are made out of, to make something that surpassed adamantium in strength but was lighter than aluminum, or mithril, and be stable and potentially even insanely heat-resistant given its sheer thermal capacity. Or we might make changes to other material properties like thermal conductivity, electrical conductivity, specific heat, half-life, friction coefficient, viscosity, transparency, and opaqueness, how well it interacted with other particles, and indeed if it could interact with neutrinos or dark matter. Direct warping of space-time can also accomplish effects like cloaking, as a given bubble of space might just fold in on itself to hide an object, or warp right around it so that light and other particles could just detour. Though one could imagine ways to detect effects like that, such as a radar beam that had a built-in timestamp, like if you were transmitting the date and time rather than just a big pulse of radio, and you could notice that the radio wave came back just a little slower or faster than it should from some seemingly empty place, though still very hard to do in empty space. In practice, a one-time pad of time-specific numbers would be better than the actual time code built into your pulse too, as that would be harder to emulate. There are many other ways we could imagine warping reality to cause invisibility or other stealth effects too, though each that comes to mind do offer some implied way to detect it, even an option like creating a huge bubble of space inside a smaller region, so you could hide a whole fleet or planet inside a spot the size of a basketball, but that still leaves something to detect. Hammerspace is the nickname for when we make a big pocket of space somewhere, as a call-out to the old Looney Tunes cartoons where some character would pull a big hammer or mallet out of thin air to whack someone else on the head with. And this is also often called a bag of holding. It's joked that many shows or movies where characters have guns they fire like crazy but never seem to need to reload have Hammerspace ammo magazines. We also see a different application in Doctor Who with the TARDIS, which is bigger on the inside than the outside, having some sprawling complex of rooms squeezed into something the size of a police box. As I mentioned a moment ago, this makes for a rather good method of stealthing a ship, or a civilization, as you might squeeze a whole fleet or planet into something basketball-sized. However, you need to think about the side effects of this, like what's happening to all the heat generated inside that basketball or police box. It's great for storage, but not if you want to be doing anything else. As we often mention in regard to future mega-civilizations, how fast a planet or Dyson swarm can radiate heat into deep space controls how much power they can use, because if they exceed their radiating rate, they'll get hotter. How fast stuff radiates heat is based off its temperature and its surface area, so if you only have a square meter of basketball or beach ball sized space to radiate heat, but you're running an entire battle fleet or K1 civilization in there, either you're going to get roasted pretty quick as the heat rises, or that bit of warped space is going to punch all that heat out of its limited surface area by growing hotter. In the case of a K1 civilization, that would be about 2 times 10 to the 17 watts coming out of a single square meter, which would require a temperature of 1.4 million Kelvin, with a peak wavelength in the X-ray range and gushing of plenty of visible and ultraviolet light. Not any stealthier than a planet. Though it might take time to warm up, and for that matter, it's a great way to cool something off too, since we'll be getting way less new sunlight in to warm it that way. It also depends on how you're doing your space-time bending. For instance, something like a shell world around a black hole, especially a big natural black hole, or even a supermassive one like a Birch planet, is bending space-time a lot. Time runs slower there and space is more compact nearby. But light is curving in from a nearby star, so it isn't missing light from that compaction. However, that light is blue shifting, which would be a way to make a red dwarf star nearby a little brighter and whiter when it got to the mega planet. We usually assume the larger ones are using artificial sunlight made close at hand on the ones that are more massive than actual suns anyway. You could use tricks with gravity or space-time warping just to make a star brighter or cooler. We could redshift or blue shift light coming out of it, or do that right above the planet we want to light, or we might increase gravity in the core, or the probability of fusion occurring. Instantly, this can be done in mundane fashion by simply placing 2 polar statite mirrors over a star, bouncing their light back on the star to heat it, which is called star boosting, or to increase the equatorial brightness out from the star, as we looked at doing for Alderson disks. In this same vein of thought, you could also make a planet radiate heat faster by expanding space right around it, and it just depends on how easy this tech is to work with, as you might have some expanded shell of space around a planet for low orbit with stratoscrape or space towers reaching into it that will 1 part space dock and 1 part radiating fins, giving you more room for spaceships to dock and maneuver too. You might also be able to dissipate heat faster by locally altering the physical constants covering how much energy is emitted by a hot object or carried in a photon it emits. Tractor beams are another example of how we might warp space. This can obviously be a product of directed gravity or anti-gravity, something like a gravity laser, but we might also imagine we learn to warp things in a directed rather than omnidirectional fashion. You could then have a planet that emitted most of its gravitational tug off its polar regions, making it easier for ships to land or take off from the equatorial range. Directed gravity also makes for a great way to launch a ship or slow it down, or for that matter, launch a bullet, shell, or escape pod. Assuming your gravity is roughly uniform coming down the barrel or being pushed by a beam, everything accelerates evenly, so we don't get those uneven crushing effects from high G acceleration. This means you can launch ships very quickly, and possibly simply powered by an uneven gravity field over your planet or structure, without holding the crew on board. Needless to say, an uneven tractor beam could be a pretty vicious weapon all on its own, ripping ships and people and even planets apart. While time travel is one obvious way to use space-time warping, temporal manipulation offers lots more options than just that, including ones that wouldn't automatically open the door to time travel and paradoxes. A temporal tractor beam, for instance, might just be something you could use to yank things from the past or future, or might let you cause time to run slower or faster under its influence, same for slow time bubbles or fast time bubbles. You might have regions of a planet or megastructure space habitat where time ran slower or faster, maybe the equivalent of freeways where time sped up to speed up travel without dangerously high collision speed. Indeed, you might use this for tricks like accelerated growth or faster heat radiation. But you have to be mindful of unexpected problems. For instance, if I suddenly slow time down in a bubble right around me, not only is that likely to have weird effects at the border where atoms are interacting, but in that bubble where time is running at, say, 100th normal speed, everything should be rather blurry outside from the fast-forward effect. However, I'm also getting 100 times the photons hitting my eyeballs and body every moment, so I should be getting very hot and need some serious sunglasses at noon. A planet placed in a slow time bubble, like Cricket from Douglas Adams' novel Life, the Universe, and Everything, has this same issue. You should be setting up some sort of mirror field with this, or solar shades, to drop the sunlight down to a rate your planet can absorb at its relative time passage. Same for cosmic rays, or you might lose the atmosphere. A fast time bubble would seem like an awesome way to build up your forces or resist an attack, or do science and production in general, but now you need to increase the sunlight coming in. For a controlled stasis field, just a place where time moves very slowly or not at all, this can be a problem. For instance, one issue with freezing people for very long interstellar voyages, those of several centuries, is that our bodies contain small amounts of radioisotopes, and the equivalent of 3,000 years of half-life decays would be a lethal radiation dose for most people. Your own body killed you. Particles keep decaying even when it's cold. This isn't an issue in a stasis bubble, as presumably time itself is stopping or slowing, so radiation decay with it, but radiation coming in from the background is, and on Earth. Natural background radiation tends to run a few millisieverts a year. Half of that is inhaled or ingested, so it presumably isn't an issue in a slow time bubble, though where you're getting your air from in your fast time bubble is a concern, and that still leaves around a millisievert a year you're absorbing in your slow time bubble. A sievert will get you light radiation poisoning, and a few will usually kill you after a month or two. More than 10 might kill you in minutes. That means your stasis field better have some thick shielding on it, or a century in, it will make you sick. A millennia will give you a modest chance of death after a month or so, and 10,000 years will give you acute radiation poisoning that will soon see you wishing you were dead for the few remaining hours of your life. And a lot of places are way more radioactive than the average, both in terms of regions and specific places, like your nuclear reactor powering your underground bunker and its stasis fields, which pass the workplace safety limits easily, so nobody thought to mention it was 10 times the normal dosage, or your spaceship, where radiation is probably a lot higher, or even on a mountaintop bunker, with less air protecting you from cosmic rays. A fast time bubble you put someone in might also cause them to detonate, albeit it would probably be their asphyxiated or starved corpse, just from all the heat or radiation they're leaking out with nowhere to go. These sorts of effects are very important to consider with any sort of reality warping. I should also note that stasis can potentially be done under known physics by placing lots of gravity nearby, which you might be able to do with careful stable arrangement of micro black holes, though these probably need to be in the gigaton plus range to avoid Hawking radiation incineration, and you will need a lot of them, but this would work under known physics. When it comes to ultra-fast communication, very thin lines of fast or slow time, much like compacted areas of space, can be great for allowing objects or signals to move quickly, and this need not necessarily violate causality or require insane amounts of power or negative mass. In this same way, we could contemplate a very long thin corridor of some hyperdense material, which would slow time down inside it and compress space, but you can't send a signal down that. It would get absorbed by all that matter, Though as we discussed in our dark matter episode, since dark matter interacts with normal matter and photons either very little or not at all, a message might travel down one undistorted or attenuated even over light years. We call that a dark telegraph in that episode, see it for more details. Compressing spacetime itself might have a similar effect, but takes us to the concept of vacuum energy. Space is never really empty. There are always stray atoms or photons moving through, but even a shielded volume sucked free of material will still have lots of particles and antiparticles popping in and out of existence constantly. There is a lot of debate as to if it is possible to ever tap this for power, and how much you get out of it if you did, but if you can compress space-time or alter reality and make these virtual particles last longer or remain around, it would make for an amazing source of matter and energy, though it's the sort of thing that could conceivably cause a Big Bang-like effect as well. Universe creation by playing with vacuum energy, or even just by chopping off new bubbles of spacetime or existing sections as subverses, seems very plausible if you have reality warping technology, and may occur unintentionally as a result of playing with spacetime or physical constants too much in an area. You might also make universes that were of more dimensions, or where time is curved around like a loop, or space was shaped like a donut or ring, running back around on itself, ones where laws of conservation of momentum or energy didn't apply, or other types of matter existed, or even types of dimensions or traits that didn't exist in this universe. You also might be able to travel to other universes this way or get them leaking in, which might be problematic if a neighboring reality with twice the gravitational constant you have starts leaking into your sun, rapidly accelerating fusion rates. Probability manipulation and luck is another way you might alter fusion rates of particles. Your typical proton banging around a stellar object will ricochet off other protons many billions of times before we get the result of them sticking together and transmuting from a diproton into deuterium, a proton and neutron, and while winning at the lottery or dice might seem an obvious way to profit off messing with probability, being able to screw with probability at an atomic level probably allows very cheap fusion, long-lasting rare isotopes, and would have lots of applications besides simply being an amazing power source and weapon. As an impact on a civilization, it might turn games of chance into games of skill, and really mess with things like insurance rates. I could imagine someone committing murder by increasing someone's chance of having an accident, or alternatively, reducing the odds of accidents or catastrophes which brings civilization to crisis or even collapse. When folks say something like, anything that can happen will, given a long enough period of time, that does not hold when you can warp the nature of reality itself and play with time and probability. If you want to have a perpetual civilization, you need a perpetual supply of power and matter, and there are a number of ways that warping reality could allow a perpetual motion machine or other eternal power supplies, some of which we discussed earlier. But if you can play with time and space and probability to harness unending resources and predict catastrophes or reset from them, or to suck spacetime in to power yourself and keep galaxies from flying apart, well, there's no reason you couldn't last for the better part of forever. After all, when you can warp reality itself, it lets you change the rules of the game. Of course, it lets other people do it too, and I could imagine some terrible wars being fought by those with these abilities, ripping spacetime apart and causing waves of paradoxes to crash into each other. I don't think it would be an understatement to say that such conflicts could threaten reality itself, but then again, the winner might be able to reforge a new one of their liking afterwards. So as a quick reminder for those in the Dallas, Texas region, this weekend is the 2023 International Space Development Conference, starting today, Thursday, May 25th, and running through Sunday the 28th. That is hosted by the National Space Society, which I have the honor of being president of, and I'll be there Friday afternoon through Monday. I'm certain it's going to be awesome and informative as usual, and if you come by, make sure to come up and say hi. We are not having our usual end-of-the-month livestream Q&A this weekend though. Hopefully we had it last weekend. That was a bit in the air as of when I wrote and recorded this. So today is our last episode for May, though we still have an episode image poll coming up this weekend to help select future episodes, which I hope you'll take a minute to vote in. Speaking of future episodes, next week we'll begin June with a trip to the edge of the solar system to discuss colonizing the Kuiper Belt. Then in 2 weeks, we will explore how we can build enormously tall and strong structures in space towers. then it'll be time for our Sci-Fi Sunday and a return to the Alien Civilization series for a look at higher dimensional aliens. And in 3 weeks, we'll ask what it would be like if we or some other more advanced life form sought to construct artificial afterlives. 4 weeks from now, we will celebrate SFIA's 400th regular Thursday episode with a look at life in the year 2323 AD. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you want to donate and help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content at go.nebula.tv/isaacarthur. As always, thanks for watching and have a great week.